Okay, Chapter 2, Section 2, Speed and Velocity. So the first thing we're going to talk about is our average speed. The basic formula for our average speed is our distance divided by time. And remember, there's a thing such as distance and displacement. So when you're trying to calculate the speed, you have to make sure to use the distance. The important thing about speed is that speed is a scalar quantity, so it has no direction. So we wouldn't say that speed is going to east or to north, we would just say it has a magnitude of a certain integral or a number. So we would never be able to get a negative speed. This makes sense because you can't get a negative distance or a negative time. So therefore there's no way you can get a negative speed.
Yeah, stop screaming, bro.
Okay, average velocity. So our average velocity equation is our displacement divided by time. So our initial distance minus our final distance divided by our initial distance divided by time. The important thing about our velocity is that velocity is a vector. Therefore, it does take into consideration our magnitude and direction. This is going to be important for differentiating between our velocity and our speed. We know that speed is a scalar quantity, so it has no direction, and velocity is a vector quantity, so it does have direction. Some questions are going to ask you for the speed, and some questions are going to ask you for the velocity. So making sure that you include the direction in velocity and not in our speed is going to be very important to making sure that you get the right answer. Our SI unit for velocity is meters per second, or m/s. This is the same thing for our speed, so they have the same SI unit. So whenever they give us a problem and they give us, let's say, kilometers per hour, we would have to convert that to meters per second in order to use them into our kinematic equations. Instantaneous speed and velocity. So our instantaneous speed is basically, or velocity is basically our speed and velocity at a certain point. So usually when they ask us for our speed or velocity, they're talking about a time interval. So they'll give us maybe 8 seconds. But our instantaneous velocity is going to ask you for your velocity or your speed at a certain time. So it's going to be a very short amount of time that you would have to find the exact speed or velocity during that point. Okay, so our first, check your understanding. This question says, is the average speed of a vehicle a vector or a scalar quantity? It's going to be a scalar because we know that the average speed of anything is always going to be scalar, so the answer has to be scalar. Okay, this problem says 2 buses depart from Chicago, one going to New York and one to San Francisco. Each bus travels at a speed of 30 meters per second. Do they have equal velocities? Okay, so this question assumes that we know that New York is on the East Coast and San Francisco is on the West Coast. And we know that Chicago is around the middle, or in between those two areas. So the other important thing to know here is that velocity is a vector, so we have to take into consideration our direction. So we would start off with Chicago in the center, then we would draw New York to the east, and we would draw San Francisco to the west. So when we say the velocity of something going towards San Francisco from Chicago at 30 meters per second, we would say it's negative. This is because our quantity is going due west. And on a number line or a coordinate plane, we know that all values to the left side or to the west of our 0 are negative. So we use the same thing in physics to determine whether something's going in the positive or the negative direction. So using that same concept, we would say that the bus traveling toward New York would be in a positive direction. Therefore, since their directions are opposites, their velocities cannot be equal because they're not going in the same direction. Okay, this problem says one of the following statements is incorrect. A, the car traveled around a circular track at a constant velocity, or B, the car traveled around the circular track at a constant speed. Which statement is incorrect? Okay, so the important thing in this question is that velocity is a vector and speed is a scalar. So when we draw a circular track, when something's moving in a circle, it's constantly changing direction. Therefore, if we were to draw our velocities, we would say at different points they would have different directions. Therefore, statement A would be incorrect because our velocity changes directions, therefore it's not constant. Okay, so this question says a straight track is 1,600 meters in length. A runner begins at the starting line, runs due east for the full length of a track, turns around and runs halfway back. The time for this run is 5 minutes. What is the runner's average velocity and what is his average speed? So again, we're going to use the concept that velocity is a vector and that speed is a scalar. So if we were to draw our track, we would say that's 1600 meters in length. And we're calculating our velocity, our time is 5 minutes, which would be converted to 300 seconds because the SI unit for time is seconds. So when we're calculating our velocity, we would say that his distance from the track at the beginning is 1600 meters, and then he went back 800 meters, we would subtract that 800 meters from his original distance. This is because we use the concept that displacement is your distance from original point, not your overall distance traveled. So we would do 1600 minus 800 and divided by our time of 300 seconds to give us 2.67 meters per second. Now we go into our speed. So the speed would be the opposite. We know speed is distance divided by time. Therefore, we would do 1600 plus 800, which is the total distance that he ran, and divided by 300 to give us 8 meters per second. So there we see that concept of making sure you know when to use displacement and when to use distance. It's going to be very important when you're having to calculate our velocity and our speed, as we saw in this problem. Okay, so number 6 says the average velocity for a speed has a positive value. Is it possible for the instantaneous velocity at a point during the trip to have a negative value? So the answer to this is yes, it is possible. And this one's a bit tricky. So if we were to draw a number line, or a line showing the intervals of our time, we would draw intervals of maybe 5. So we would say that the distance traveled at each interval is 5 meters, except for one interval where it travels a distance of negative 5 meters, so it would be going backwards. However, your average velocity can still be positive if your overall velocity if your overall displacement is still a positive value. So we would say that the instantaneous velocity at the point where it covers a distance or a displacement of negative 5 meters, we would have a negative instantaneous velocity. And we could still have an average velocity that is positive if our overall displacement is positive. Okay, so this problem says you step on a hot beach with your bare feet. A nerve impulse generated in your foot travels through your nervous system at an average speed of 110 meters per second. How much time does it take for the impulse, which travels a distance of 1.8 meters, to reach your brain? So they give us our speed of 110 meters per second, and they give us our distance of 1.8 meters. So here the trick is to use our speed formula. We know that our distance is 1.8 meters and our speed is 110 meters per second, so we can calculate our time. So we would say that our time is 0.016 seconds, which makes sense because nerve impulses are really fast. So in order for it to travel to your brain, it would take 0.01 seconds. Okay, so this problem says a tourist being chased by an angry bear is running in a straight line towards the car at a speed of 4 meters per second. The car is a distance d away. The bear is 26 meters behind the tourist and running at 6 meters per second. The tourist reaches the car safely. What is the maximum possible value for d, or distance? Okay, so we go 4 meters per second for the man, and they give us a velocity of 6 meters per second for the bear. So the trick here is to know that the guy reaches the car, or the tourist reaches his car, before the bear can reach him. So we have to assume that the time it took the bear to reach him would either have to be more or just about the same amount of time that it took for the man to cover the distance. Since the bear was 26 meters behind the man and it was traveling at a velocity of 6 meters per second, we would say that the time it took the bear to reach the man would be about 4.3 seconds. So we can use that time to find the distance by saying that our distance divided by our velocity would give us the time. and we find that our time would be 1.72 meters. I'm sorry, 17.2 meters.